Hello, I'm Brian Schmidt.
And I'm Paul Francis. I'd like to start with a story. On the 27th of October 2012, astronomers at La Silla Observatory in the Atacama Desert in Chile noticed something rather strange. They had a picture of galaxy NGC 1365 and they noticed a new object had appeared in its outskirts, what looked like a new star.
Within a few minutes of this announcement, my team was able to train a powerful spectrograph up at Siding Springs Observatory onto this new object. What we saw was a blast wave of silicon, calcium, and iron expanding at nearly 15% of the speed of light. This could mean only one thing. The object was a Type 1a supernovae, an explosion of a tiny little star known as a white dwarf. Now, this object's light had only been traveling for a mere 56 million years, meaning that this was one of the closest of these types of explosions that we had seen in over the past decade.
When first spotted, it was only as bright as 100 million stars. Pathetic, hardly worth bothering with. But a couple of weeks later, it had swelled to its full magnificence and was outshining an entire galaxy. So here we had an explosion of something scarcely bigger than a planet that could outshine an entire galaxy. These are pretty amazing explosions. And they're not rare. Somewhere in the observable universe, one of these supernovae explodes dozens of times a second.
The universe is indeed a violent place. In this course, we're going to look at all the deadly violent things in the universe. Black holes, quasars, supernovae, gamma ray bursts, and neutron stars.
We will look at where these things come from, how they explode, how we know anything about them, and how they can completely lay waste to everything around them.
And curiously enough, we're also going to look at their creative side. Because without these violent explosions, planets like the Earth and life as we know it simply could not exist.
This course is one of 4 that together make up the Australian National University's first-year astrophysics unit. You can do any of these courses by itself, or you combine all 4 to get an overview of modern astrophysics.
The other 3 courses include an introductory course on the great mysteries of astronomy, as well as a course on exoplanets, and finally, a course on cosmology. Now, to get the most out of these courses, you really need to have a solid understanding of high school level physics and math.
We hope you will join with us in studying these, the deadliest places of the universe, and how they are fundamental to our very existence.